Hey everyone, today we are looking at what's called conditional probability. So we're back to our example on can you taco tongue and evil eyebrow. So the question that we're exploring today is, are the events yes taco tongue and yes evil eyebrow independent? This is a new vocabulary word for us today. So I have our data here from yesterday with those that were yes, evil eyebrow, and yes, taco tongue. So same data from yesterday. So let's explore this a little more. Part 2 says, given the person selected is yes, evil eyebrow, what is the probability that they are yes, taco tongue? Okay, so here we have this new kind of keyword given. So given that the person selected is yes, evil eyebrow. So now I'm only looking at those people who are yes, evil eyebrow. So I have a total of 18 people who are yes, evil eyebrow. And then we want to know the probability that they are also yes, taco tongue. So we had 15 out of 18. And my question asked me to write it as a fraction, a decimal, and a percent. So my decimal should be 0.83, which makes my percent 83%. Okay, so how do I write this as kind of in probability notation? Both of these two examples are what we call conditional probabilities. Okay, with conditional probabilities, we always have a condition, and my keyword, like I said, was given some sort of a condition. So here I'm going to write the probability. We're looking for the probability that we are a yes, taco tongue, given, okay, this little line right here means given that we are yes, evil eyebrow. Okay, and the backside of this is always our condition. So the part that comes after the given line is our condition. So what is this probability given we have some sort of a condition? So let's see if we can apply this in our next one. Given that the person selected is no evil eyebrow, what is the probability that they are yes, taco tongue? So now we're looking out of 12 people, because we have 12 people who are not evil eyebrow. We have 5 that are yes for taco tongue. And so that comes out to 0.42 or 42%. Okay, so if I were to write that in probability notation, I would have the probability of being yes, taco tongue, given no evil eyebrow. Okay, so as I write this, the top is always going to be that both are happening, and the bottom is my given condition. Now we're given a definition. It says 2 events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. So we want to know is, are the events yes, taco tongue, and yes, evil eyebrow independent? So what I'm looking at here is, if I look at yes, evil eyebrow compared to no evil eyebrow, is the ability to taco tongue the same? Okay, and I can see that no, it doesn't. Okay, actually type this answer out. So I can say no, people who can evil eyebrow are much more likely, 83% compared to 42%, to be able to taco tongue. So these are not independent. Taco tongue and evil eyebrow are not independent because these are not the same probabilities. But let's consider the data from a different class. Okay, so here's the data from this class. We want to find the following probabilities. So the first one says yes for taco tongue. So yes, taco tongue, I had 24 out of 30, which is 0.80 or 80%. Okay. Let's look at the probability of yes, taco tongue given yes, evil eyebrow. So now I'm taking it out of 10 people who can evil eyebrow, and I had 8 who could also taco tongue. So again, that's 0.8 or 80%. And then the probability of yes, taco tongue given no evil eyebrow. So our condition is no evil eyebrow. I've got 20 of those people that can do that. And yes, taco tongue were 16 of those 20 people, which comes out to 0.8 or 80%. So now when we look, are yes, taco tongue and yes, evil eyebrow independent? Well, knowing whether or not your evil eyebrow did not change whether or not you could taco tongue. So if I were to write this as the probability of event A being yes, you can taco tongue, the probability of A given B, as in the probability that yes, you can taco tongue given that you can evil eyebrow, and the probability that yes, you can taco tongue A given that you cannot evil eyebrow, which is the complement of B. Okay. I can create a definition because all three of these are the same. I can say that yes, these are independent because the probability of A is equal to the probability of A given B, and that's also equal to the probability of A given not B, the complement of B. Okay, so that's what it means to be independent. So we have looked at how to write a conditional probability, and we've looked at this idea of independence of events are independent if they meet this criteria of this form. Check out the important ideas and application problem for some more examples and explanation.